All right, so we are going to write, solve, and graph inequalities where variables are on both sides based on a word problem. Remember that it all comes down to um, pulling that necessary information from the word problem. So you can see that some of this information has already been pulled here. You have the capacity to do this on your own, so make sure that you're thinking about what the problem is telling you. It will tell you what to do, you have to listen to it. So we know that our first person, Brian, he starts with 80 kilograms and goes up by 15 kilograms each set. So when I see that word start, I'm thinking, okay, that looks like this might be a constant. I know that the constant is typically where I'm starting from, especially in the real world. And we know he's increasing by 15 kilograms each set. That term each is telling us that the more sets there are, the more weight he's going to be pushing. So now we know our other person, Eddie, starts with a weight of 110 kilograms and he increases the weight by 10 kilograms per set. So pay attention, goes up and increases. Those mean the same thing. They are not the same words. A lot of times you will see see these types of things in problems where the words aren't the same, but the meaning is the same. So pay attention to that. So think about the context of the word and what it actually signifies. And we know that we're looking for the possible number of sets they can do in order for Brian's final set weight to exceed Eddie's final set weight. So we're looking to compare their two sets of numbers, and we're looking for Brian's to be more than Eddie's. So when we're going through our information, we know that Brian's starting weight was 80 kilograms. That's going to be our constant. And he is increasing by 15 kilograms per set. That is his coefficient. And with Eddie, his constant, his starting weight is 110 kilograms. And he is increasing by 10 kilograms per set. So really to set this up and solve it, all we need to do is keep consistent as to when we're starting where's Brian's side, where's Eddie's side. So I know that we're starting with Brian. I'm going to just keep him on the left the way I have it set up already. So he's starting at 80 kilograms, and then every set he is increasing, which is telling me to add 15 kilograms. But our unknown value here, X, stands for number of sets, and then the implication beyond that is that they need to do before Brian's weight's going to exceed Eddie's, because we know right now at the start Brian's weight is less than Eddie's. So he's doing 15 more pounds per set. Exceed means that we want Brian's to be bigger, so exceed is greater than, and then we have Eddie, 110 kilograms to start, and he's going up by increasing by 10 kilograms per set. So same way as you would solve an algebraic equation with variables on both sides, we've got to consolidate that variable. We've got to get it to one side. I typically like to move the smaller variable using my property of equality of addition or subtraction property. So they're both positive, so my smaller variable is 10x. It is positive, so we're going to move it by using the subtraction property of equality. Same thing on both sides. They zero out on the right, but on the left, 15x minus 10x gives us 5x. So I have 5x. Everything else is going to come down with it. 110 didn't do anything to it. 80 didn't do anything to it. 15x minus 10x is positive 5x. And now we're ready to continue moving. So now just two-stepper, properties of equality. I can see that 80 is being added. Its invisible sign is positive, so the only way to zero it out is to subtract 80 from both sides of this inequality, and then I am ready to bring down my 5x, and 110 minus 80 is 30, so I have 5 times x is greater than 30. Opposite of multiplication is division, so I'm going to divide each side of this inequality by 5, the division property of equality, and 30 divided by 5 is 6. So he needs to exceed 6 sets. So they need to do more than 6 sets. So do more than 6 sets. So 7, 8, 9, 10, etc. Those number of sets will work, and that will make Brian's final set weight exceed or be more than Eddie's final set weight. And so our last step here is graphing our inequality. So we're going to draw our number line as per usual. Since we're doing it ourselves and we're not plotting it on anyone else's number line, we can do it the easy way. Plot out our number 6. It needs to be greater than 6. So greater than is an open circle. We do not fill it in because it can't be 6. 6 will give them an equal weight. We need to be more than that because we don't want their weights to be equal. We want Brian's weight to be more than Eddie's weight. So anything over 6 works, but not 6 itself. And then it needs to exceed. It needs to be greater than. So we're going to point this guy to the right. And then we have solved our word problem.